What is math world? Hello, welcome back to Math. Today we're going to talk about double angles. And the first double angle we're going to refer to or find out is cosine of 2 theta, or double angle of theta. Now, if we go back to a right triangle, or you can remember back to the unit circle, if I'm given this particular right triangle here, we know this is a right triangle, and we have this angle theta, we know that obviously this angle up top is nothing more than half pi minus theta, or 90 degrees minus theta, because we know that the total degrees of triangle is 180 degrees, or pi. And we also know that the side opposite, this theta right here, the side opposite right there, is going to be the value of sine of theta over 1, which we know obviously is just simply sine of theta. So what we're going to do now is we're actually going to reflect this triangle over itself. And we've done this in previous examples, but by doing this, essentially what I'm doing is I'm creating a bigger triangle. This angle obviously is also theta. This is obviously all pi over 2 minus theta. And this side right here, this little side length, is also sine of theta. But what I've created now is a double angle, or 2 theta. This has a value of 2 theta. And we know this has a side length of 1. So not only does this angle have 2 theta, but what we have also created is an isosceles triangle with both legs equal to 1, and obviously congruent base angles of half pi minus theta. So we want to find out what this cosine of this 2 theta is equal to. And what we're going to use actually is the law of cosine, something that we've done in the previous sections. So in this isosceles triangle, this is one leg and this is the other leg. It doesn't matter which one. I'm going to designate this one as A, this one's B, and that makes this entire side over here my C side, and that makes my big angle C over there. And going back to my laws of cosines, I know that C squared is equivalent to A squared plus B squared minus my 2AB cosine of C. And the advantage of that is you can see that my C side now is nothing more than 2 sine of theta quantity squared. And one of my A sides is 1 squared, the other one, B squared, is 1 squared, minus 2 times 1 times the other one, times cosine of C. In this case, cosine is 2 theta. And that's going to help me solve for my double angle of theta. Now from here, this gives me a value of 4 sine squared of theta is equivalent or equal to 2 minus 2 cosine of 2 theta. And again, the angle I'm interested in is the cosine of 2 theta. So I'm going to divide everything. First of all, let's get rid of these 2's. I'm going to divide everything by 2. So I'm left with 2 sine squared of theta is equal 1 minus cosine of 2 theta. And once again, because I am solving for this value here, my cosine, I'm interested in the double angle of 2 theta. That leaves me with cosine of 2 theta is equal to 1 minus 2 sine squared theta. And this leaves me with my first double angle cosine of 2 theta, or double angle identity. And that is that value right there. And we should also be comfortable with the trig identity cosine squared theta plus sine squared theta equals 1, which obviously leaves us with sine squared theta equals 1 minus cosine squared theta. And using that identity, we can sub that value, and this leaves me with an alternative double angle cosine identity, which comes out to being 1 minus 2 times 1 minus cosine squared of theta, or simply 1 minus 2 plus 2 cosine squared theta, and obviously that equivalent, or comes out to being 2 cosine squared theta minus 1. So this is an alternative identity of the double angle cosine right there. The third identity comes from reworking the second identities, and that simply is the cosine of 2 theta equals 2 cosine squared minus 1. We should also obviously be comfortable that 1 is equivalent to the cosine squared of theta plus sine squared of theta. And if we substitute that value into the second equation, I'm left with 2 cosine squared theta minus the quantity cosine squared theta plus sine squared theta. And that leaves me with my third identity, which is simply cosine squared theta minus sine squared theta is equivalent to my 2 cosine of double angle theta. Here's an example that Professor Axler asked us to do. Suppose theta is an angle such that cosine of theta equals 3/4. Evaluate cosine of 2 theta. Well, again, I have 3 possibilities for my cosine, my double angle of a cosine. I have 1 minus 2 sine squared theta, 2 cosine squared minus 1, or the cosine squared theta minus sine squared of theta. I need to choose the one that's most appropriate for the question that's asked. In this case, I've been given only my cosine value. So out of all these identities, I need to come up with the one that has that value in it, and that's going to be my second identity. So I'm saying that cosine of 2 theta in this case is going to be equivalent to 2 times the cosine squared of theta minus 1. And obviously cosine of theta in this case is going to be 2 times my 3/4 squared minus 1. And that's going to be obviously 2 times 9/16 minus 1. And that's obviously going to be 18 over 16 minus 1. It's going to give me 18 over 16 minus 16 over 16, which leaves me, well, obviously with 2/16, or equivalent to 1/8. So cosine of 2 theta has a value of 1/8. Now to find the double angle of sine, we use our same triangle that we created before with the law of cosine, except now we're trying to find 2 sine. We know that this value obviously right here is twice sine of theta. We're comfortable with that. And using the law of sines, we can see that this is the angle I'm interested in here, and that tells me that the sine of that double angle, is equivalent to over that side is that value opposite that side, so that's going to be 2 sine of theta, and that's going to equal the same thing as one of these angles, which we're going to call the sine of pi over 2 minus theta, all over the side that it's equivalent to, which is going to be 1. So that is my formula to help me set up using my law of sines. Now equating this, we come up with this. The first thing we need to be comfortable with or identify is drawing back from the past that basically the sine of half pi minus theta, that's equivalent. That is equivalent to, from our previous chapters and previous videos, that is equivalent to cosine of theta. So this guy can be written now as sine of 2 theta over 2 sine of theta is equivalent to cosine of theta over obviously 1, which after equating out gives me the value when I solve for sine of 2 theta is equal to 2 sine of theta times cosine of theta, or equivalent form, which is 2 cosine of theta sine of theta. So that is my identity for the double angle of sine. Professor Axler asked you to do an interesting thing here in example 2 in the book. It says, knowing that cosine of 30 degrees is square root of 3 over 2 and sine of 30 is 1/2, evaluate sine of 60 degrees. Obviously we should know the sine of 60 degrees, but let's use the double angle formula to see if this is indeed the case. We need to agree, first of all, that 60 degrees is nothing more than twice the 30 degrees. And I have the cosine value of 30 degrees and sine value of 30 degrees. Therefore, evaluating that value of 2 theta, which is going to be 2 times the 30 degrees, I need to evaluate the cosine. I need to evaluate the cosine of theta times the sine of theta. And obviously, with this essentially being sine of 60 degrees, what I'm really asked to do is find cosine of 30 degrees times the sine of 30 degrees. And let's see if this ends up being true. So we know that the cosine of 30 degrees is nothing more than the square root of 3 over 2, 2 times 1/2. And that comes out to being square root of 3 over 2. And is that the sine of 60 degrees? Yes. So it comes out to being true. So there's an example of how the double angle formula can work for you.